Good morning, students. Today we are going to discuss the new chapter, that is chapter 3, motion in a straight line. Now let me discuss a little bit about the theory part of this chapter, then we will go for the mathematics part. Now the first topic which we are going to discuss, I think most of you know. If someone asks you what is motion, so as per our knowledge, any object, if it changes its position with respect to time or with respect to surrounding, then we can say that the object is in motion. If it does not change its position with respect to time or with respect to surrounding, then the object is at rest. So let me read out what we have written. An object is said to be in motion if it changes its position with respect to surroundings with the passage of time. So this is a very simple one. I think most of you know. Now you see, motion is a relative term. Relative, why I have said related to surrounding, you can say. Suppose you and your friend are traveling in a car. Now the car is moving, but you and your friend is at rest, is not it? So with respect to your friend, you are in rest. But if someone observes outside the car standing on the street, then definitely with respect to that person, your friend is in motion, or you can consider yourself is also in motion with respect to the person which is on the street. So motion is a relative term. So in some cases, with respect to some frame of reference, an object is said to be in motion, but with respect to some other frame of reference, the object may be at rest. So what we have written, an object in one situation can be in motion, but in another situation, same object can be at rest. So motion is a relative term, and simultaneously rest is also a relative term. Now regarding the classification of motion, motion can be classified as per your syllabus, three different types. Now number one is your translatory or rectilinear motion. Now the second one is your rotatory or circular motion, and third one is your oscillatory or vibratory motion. Now let me define each of these motion in brief. Now first motion which you are going to define is your translatory or rectilinear motion. So translatory motion, what we have written, let me read out. It is a motion in which a body is moving such that all the particles constituting it move simultaneously along parallel straight lines, and all the constituent particles shift through equal distance in a given interval of time. I think it is very simple. You can consider an example of an object which rolls down over an inclined plane. So that is your translatory motion. Now rectilinear motion is very simple. It is the motion along a straight line, and translatory motion is also the motion is along a straight line. So that's why we have written translatory or rectilinear motion. Now second one is your rotatory or circular motion. So what we have written, let me read out. A rotatory motion is that motion in which a body is moving such that all the constituent particles move simultaneously along concentric circles having their centers lie on the line called axis of rotation, and all the constituent particles shift through equal angle in a given time. So you can consider you have you have a sphere, solid sphere, and a stick passes through its top to bottom through the center. So if you rotate that one, then that stick behaves as an axis of rotation, and motion of that spherical object about the axis of rotation is nothing but the example of rotatory motion. So you can define this motion as your circular motion also. The circular motion is nothing but an object which moves in a circular path. Now the third one which you are trying to define is your oscillatory motion. So I think all of you know this type of motion is nothing but the oscillation of a pendulum. So what we have written, let me read out. The motion in which the body moves to and fro or back and forth repeatedly about a fixed point in a definite interval of time is called oscillatory motion. So this is the example of motion of a simple pendulum, and the mean position you can consider the position of rest, and about that mean position the pendulum bob is oscillating one time left side, one time right side. Now as we are discussing motion in a straight line, so it is nothing but the motion in one dimension. So let me define what is motion in one dimension. The motion of any object is said to be one dimensional if only one out of three coordinates is required to specify the position of the object with the passage of time. So three coordinate, I think all of you know, x, y, z. So if you need only x to define the motion, then it is your one-dimensional motion. Basically, in one-dimensional motion, the object moves along a straight line or well-defined straight path. Motion in two dimension, this is our next topic. So we are not going to discuss here motion in two dimension. Now it's very simple, but you must have to know. Now frame of reference. Suppose as we have said that motion is relative, is not it. So you need a frame of reference to define the motion. In some frame of reference, an object may be at rest, but in some other frame of reference, the object may be in motion. Okay. So if you consider a frame of reference inside the vehicle and the vehicle is moving, so with respect to that frame of reference, you yourself you can consider as rest. But if you consider a frame of reference outside the vehicle, then you have to consider yourself is in motion. So what we have written, let me read out. Frame of reference is a system of coordinate axes attached to observer with respect to which the observer can describe the position, velocity, acceleration, etc. of moving object. So if you consider yourself as an observer, so what we have to do, you have to consider your position as the intersecting point of the three axes, or you can consider your position is at the origin. So with respect to yourself, anything which is in motion you can describe by the frame of reference. If the object moves in a straight line, then you need only one coordinate. If the object moves in a plane, then you need two coordinates. And if the object moves in space, you need three coordinates to define the position, velocity, acceleration, etc. of the moving object. Now next topic is nothing but is your distance. So I think all of you know it is the length of the actual path traveled by the object in the given time during the motion. Okay, so SI unit is meter and CGS unit is centimeter, and distance basically is a scalar quantity, and it is nothing but the length of the actual path. Now displacement, it is the shortest distance traveled by the object between initial to final position of the object. It is the shortest distance. It is a vector quantity. So there may be the possibility that distance may be equal to the displacement if the object moves in a straight line without changing its direction. Basically distance is of a higher value compared to the displacement. In some cases distance is equal to displacement. Now displacement is a vector quantity. You need magnitude as well as direction, and distance is a scalar quantity. You need only magnitude to describe the distance. So these topics, I think some topics you know and some topics seems to be new. So mathematics part will come slowly, but before that you must have to know this term, and definitely this term seems to be simple once you understand. So please go through this part very clearly as we move next class or after that. class, definitely we will discuss these all theory part in terms of mathematics. So if you have any doubt, please you are free to ask during the class. So this is all about. Thank you.